Good morning from the EMC Symposium in Ottawa, Canada. This is Steve Koster with EMC TV, and we're at the AR booth. AR's got several products that they're displaying this year, but today we're going to catch up with Carl Meuller. Carl's going to tell us a little bit about the Multitone system. Carl, how are you today?
Doing great, Steve.
Awesome, awesome. What can you tell us about your new Multitone system?
The Multitone system is a system built to reduce test time for radiator immunity testing.
Awesome.
On there, and the theory behind it is to do multiple signals during dwell time on there, and by doing multiple tones, you could reduce the test time significantly. Now, one example is if you had 2 tones, you could reduce it by 50%.
Right.
If you had multiple tones, you could reduce it up to 80% in time savings. By reducing all the tones, the multitone system can pay for itself within 3 years.
Oh, absolutely, because time is money in a test lab. There's no doubt about it.
Yes.
All they have to sell is time and test reports. So if you can shorten that time, obviously there's going to be some savings.
Absolutely. Now, the main component in the multitone system is the vector signal generator. Okay. The vector signal generator is what generates the multiple tones on there. Now, what I'd like to do now is to show what's inside the multitone system.
Awesome, that'd be great.
Okay, so I want to start over here
Far enough.
On the field probe. We have an FL 7006 field probe.
Fiber optic coupled?
Yes, that's fiber optic coupled to the FI 7000 laser probe, and that supplies the laser power and the communication. The FM 7004 communicates the laser probe, which displays the field strength via the field probe.
Awesome.
And then the next thing we have here is the SC 1000. That's our system controller.
Okay.
That routes the RF from the vector signal generator to different antennas or different amplifiers. So you can configure that later. And then down below here, we have a Pixie chassis, what's inside the Pixie chassis is an embedded controller, which where the software resides. And then we have a vector signal generator, which generates the multiple tones. We have a vector signal analyzer, which analyzes the forward power and the signals. And then we also have a preamp to amplify the vector signal generator's signal to the amplifier.
That's quite a lot of equipment in one little box.
Yes.
Uh-huh.
Now what I'd like to describe now is our setup here.
All right.
So what we have here is our multitone system, multitone test system, which out in the back typically has an amplifier, but for the demo we don't have an amplifier. It gets connected to a directional coupler. The directional coupler comes out here to the TEM cell here, and then we have a field probe that's going to be monitoring the field strength.
Absolutely.
On there. So that's basically the setup today.
Super.
For the demonstration.
Carl, that's quite an interesting system. Let's go ahead and look at the software, will we?
Okay, let's look at the software, Steve. Okay, basically you have 5 main menus here. And the main menus are actually equipment, test setup, field calibration, multitone calibration, and run test. Now this is all based on the IEEE 61000-4-3. Now, the difference between that and this calibration is that there's 2 parts. The traditional IEC 61000-4 just calibrates it in single. Here you need to calibrate it in tone sets.
And the multi-tone sets?
To check for linearity and harmonics here.
For each tone?
For each tone,
oh,
correct.
Yeah.
It does it for each tone.
That could be...
Yeah. So let's first thing I tell everybody is to load all your test lab equipment in the equipment list here. Here you can see we have a directional coupler, and you put all your information here, your model number, your serial number, calibration, due date, description, and then your correction factors. So any other piece of equipment that needs a correction factors, here's where you would insert all that. Right. And you can import it from a table file, from a text file. Now, after you have all your equipment loaded in and there, you're ready to do the test setup. Now, test setup, you want to set up the test parameters. Over here, you can input the frequency You can set your step size, your test level, and then your dwell here. And then in between the points, you can actually put interpolation, non-linear or log. Once you have your breakpoints, frequency breakpoints set, you're ready to do check to see if it's CW, or you could put a discrete frequency point. You can also set up the modulation. You can set up amplitude modulation, or you can set up pulse modulations by inputting these parameters here. So once you have your test parameters all set up, you're ready to do the equipment routing. Now the equipment routing goes through the SC1000 system controller. And here's a diagram showing what the SC1000 looks like. You can see from here, this is our vector signal generator, and you can actually put up to 4 different amplifiers here switching. And here's where you go and you select your amplifier in there, and then you can route it to any antenna you want here, and any combination. And if you had an antenna controller, you'd put that in here, and then the directional coupler comes back to the vector signal analyzer. And then you can put any kind of message in here that you need, that is required. So once you have that all set up, you have your system controller you select here, your field monitor, and you enable reverse power. We have 2 systems that actually measure just forward power, and then the other one is actually measuring the net power, so it needs forward and reverse power. If you have a pro positioner, you can enter that, or a turntable controller. So once you have that all, and then the next screen is actually, you can, if you have any EET monitoring, you can put parameters here and set all kinds of things to automatically monitor your DUT. After you have that all set and you're ready to, it always saves the files, ready to do the field calibration. Again, I said there's 2 parts to it. We're going to do the single tone first. So you come up here and hit the play button. So I'm going to start a new calibration since I ran one. I'm not going to save the old one. Okay, here is where I can set my field level intolerance and my power level intolerance. Okay. I can set if I'm going to do constant field or constant power leveling on there. And I can drop the level between frequency steps. I think the mill standard has you doing that. Right. There. So once you have that all set, and then my positions, here I can go put 1 position up to 20 positions. I know IEEE standard recommends 16 positions there. Once you have that parameter there, here's where you can select your antenna. In this case, I'm just going to do vertical, but you can do vertical, then horizontal, or horizontal and vertical. So it gives you a choice of what order you want to select the antenna. Once you have this, this is test information for the test report. Cool. So you can input all that, you hit run, and then it gives you a prompt what you put in from previously. Right. Start your engines. And now it's switching through. Now it tells you to go to vertical polarization. Reminds you what you're doing. Correct. And then position 1, we only have position 1 set. And if you have an amplifier, if you need to manually turn it on, it tells you to do that so you don't forget. So now what it's doing, it's stepping through the frequency steps at 20% steps at a field at 3 volts per meter. And it's recording the measured field, and it records it in this screen here. And it records how much power you need. Right. In here. So you have that all recorded. That's all recorded, and then you can save that file. So once you have that file calibrated for single tones, you're ready to do the tone set calibration. So you select down here, you hit the play button, and then here you can set how many tones you can in a tone set. What's the maximum number of tones you can use? The limitation on the maximum number of tones is 200 megahertz. So depending where you are in the frequency band, the lower frequency band, you get more tones. Right. Because if you're set 10% versus if you're at the higher end in there. Awesome. And the other limitation is how much amplifier power you have that's going to pass the linearity or harmonics. So here you can you can check for 2 dB compression. You can set that limits, and then you can set your harmonic limit to 6 dBc. We have per the IEEE 61000 standard, which defaults. Your power level and tolerance, you set that. Vertical only. This is the antenna you selected. Now you put your test information for calibration again, and you hit run. It prompts you.
Keeps giving you those little reminders.
Yes. And then here you can see that we selected 2 tones. It's actually calibrating it with 2 tones. Now, if it goes past the 200 megahertz, it will actually just put 1 tone up, one set. So it automatically does all that. And you can see RF, and it's checking for harmonics and linearity. So I'm going to save this file. Now that I'm done the calibration, I'm ready to run the test. I'll select Run Test, hit play. Here you can select how many sides for your DUT you want to test. There, and again, you select your power level, and it gives you options of how you're going to test everything as far as setting up things. If you're going to start with vertical or horizontal antenna. Once you get all that information in, you select your antenna again, and then this is all your information for test report for the test. Now what it starts, prompts you again. And now it puts up the first 2 tones. Now you can see how fast it's going through here.
Yeah,
we're only using 2 tones because we don't have an amplifier.
Right,
But if there was a problem, you can hit report event, and then you can manually go in here and change. You can select which tone it is. So you can go down back to the traditional way of testing. You can select the test level if you want to see what kind. You can set your dwell, and then you can just hit test here, and it will test it. There.
Cool.
So once you've done that, and then you can mark pass or fail on here, and you can log all the events there. So for your test report, so you can have a history of what you've tested, each individual steps. So you can go back and return to the test station, and then it goes through here. And once it's all done, you can save the file, the run file. And then the only other thing you can do with all this is, after this, you can create a report for a final test. Now the final test is going to be in a Word document.
Okay, and Words, everybody's using that.
Yes. Now once it creates a Word document, it's just like any Word document. You can edit your header here or anything, but it gives you all your test data that you ran here, your setup, your frequency parameters, your setup, and there all the equipment that you used. There's your test data, and then that's in the graphical, and this is in tabular form.
Carl, thank you for showing us that demonstration on the Multitone system.
Absolutely.
It was really good to know more about that system and to see the time savings and understand the reporting. Thank you very much. This is Steve Koster of EMC TV reporting to you from Ottawa at the EMC Symposium 2016.